point in your high school career, like if you're taking maybe pre-calculus or AP calculus course, then you've probably heard someone you know in that class talk about the product rule or the quotient rule, but one rule that people use all the time and they probably don't even know that it has a name to it, to be precise, is called the sum rule of differentiation, and this enables us to say something like d dx of some f of x plus g of x equals d dx of f of x plus d dx of some g of x. In other words, we're able to take the derivatives of each of these pieces with respect to x individually. So why are we exactly able to do this? Well, let's take an example of this and work it out with our infinitesimal changes and see what happens. So let's go ahead and call a y equal to some u plus v, or y might be some f of x equals what we can call some u of x plus v of x. In other words, the f of x can be split up into two other pieces here. And okay, so let's add an infinitesimal change to each of these parts here. So y equals, or u plus v, so y plus delta y equals u plus delta u plus v plus delta v. But notice how in this equation here, if y equals u plus v, then we have a y over here, a u plus v over here, so we can cancel these out and just look at the infinitesimal pieces. So delta y equals delta u plus delta v here. So what can we do next? Well, now we have to get it into the form of dy dx, so naturally we're going to divide all these pieces by delta x. So we're going to say delta y divided by delta x equals delta u over delta x plus delta v over delta x. And now, if you recall from the other clip that I made, the way that we find the dy dx piece is we have to take the limit as the delta x approaches 0 of the delta y over delta x piece to get our dy dx, because if you recall, we're trying to find what happens when we have as infinitesimal of a change as possible, and we're trying to find another equation to be able to describe what's happening when that's going on. So we're going to take the limit as delta x approaches 0 of all of these pieces, so of delta y delta x equals the limit as delta x approaches 0 of delta u over delta x plus the limit as delta x approaches 0 of delta v over delta x. And notice that we can use this definition now to write that we have dy dx equals du dx plus dv before we defined y to be u plus v, so that means that we have du plus v dx equals du dx plus dv dx. In other words, taking the derivative of some f of x is the same as the derivatives of each of the pieces. You can split it up into individually. So you should get used to this d and v kind of notation here, as when we get into integration by parts and things like this, or the quotient rule or the product rule, then a lot of your textbooks are going to use u and v to describe this, so I would keep that in mind. But yeah, okay, this is why this rule works, and this is going to be very important on your tests or homework, and you're going to use it probably on almost every problem, because normally your questions are not just going to ask you like what's the derivative of cosine or of x squared alone. It's going to be a derivative of some f of x with multiple different pieces involved. But fortunately for us, we're able to split each piece up, so that's going to make it easier for us. So hopefully you found this helpful, and you come back for the next one where Joe shows you how.